Okay, so welcome back again, and this is Chipmaster here, and we're coming to the end of the year, and the holiday season is coming up. So I'm doing a Christmas week repair. Today I have a box here sent to me from another shop, repair shop, and they are a bit urgent. I told them that I'm closed off for the rest of the year because I'll be on break, and they begged me and they asked me and plead and begged to see if I could repair it because it is an emergency job. So I told them I will just help them to see if I can repair. Alright, so what? An SSD drive? From which laptop is this now? I don't know. Anyway, I have a Mac here. Oh, they are disassembled. This is a Lenovo. I got it, as you can see, as is. I also have here a on boards. This is a HP 14. I have here a HP 15. I think this is parts because it said that one of the Apple boards are in there for parts. So this is a parts board. So that's how many? 1, 2, 3, 4, 5. So it's 5 boards then, or in case 5 laptops. And this is like a back cover and a battery, and that's it. So which one should I do first? Apple? Alright, I'll do the Apple. Alright, this is the parts. This is a A1502, A203476. So I'll do the Apple. I haven't done an A1502 yet. Yes, I did. Yes, I did an A1502. Yeah, I did one power failure the other day. Recent as well. This board is bent. It looks bent. Is it bent? No, it's not. A slight bent though. HP 15. 14, sorry. Alright. The Apple is urgent, so I'm going to do that first. Alright, so I'm going to do the Apple first. All of these have to repair by today. All these laptops, they should repair by today to send off by tomorrow. Alright, so I'm going over to the overhead camera. This needs adjustment. Okay, so I'm going to plug in the power. They said that it's not charging, I think. I believe, yeah. Right, so this is the MagSafe 2. So I'm plugging in the power now. Alright, we get orange, green light, and I get orange light. And as you can hear the chime. And they said that it's not charging. So it fully works. And the current is, let me show you. Can you see? The current there is jumping. It's 880 milliamp there, 840 milliamp. 600. So it's definitely not charging, because if in an on condition I should be getting roughly 3.5 ampere while it's on, in an on condition and charging. Alright, so I'm at the login screen, and I have to get I don't have the password. Maybe I have to get it from the tech, if he can get it from his customer. Alright, but as you can see there, it's not charging, so I don't really need the password. By looking at the current, I'm going to turn it off. Alright, I'm going to turn it off and see what the current is in an off condition. Alright, so it's fully off, and it's not taking any ampere, as you can see. I'm just getting standby current, which is about 15 milliamp. Let me see. So I get 14 milliamp, which was not far, correct? Alright, I get 14 milliamp. And it's not charging. So I'm going to take it apart. I will try another battery. I'll try another battery and see what I get. These are different screws. We have random screws, PC screws here. These are not the original screws. Alright, so let me remove. That one's on my hand. That's tacky. Using a regular PC screw to screw down the back of the laptop. Alright, so this is a 2015 machine. Alright, so I'm just looking at the battery connector here. Alright, this protective film plastic is not there. What I'll do, I'll get my testing battery and I'll plug it onto this connector here and see the current consumption. Alright, so I'm going to get my testing battery. Okay, so I have the testing battery here. Alright. Okay, so here's the battery. So let me plug it on. Alright, it's plugged on. Alright, so I'm going to connect the power. Alright, so let me see the current now. Alright, there's a chime. And the current is still not increasing, even though it's a new battery. This is a brand new battery. This is my testing battery. So I'm still not getting the current that I'm supposed to get. It's not going up to 3 ampere or 2 ampere thereabout in an on condition, so it's not, definitely not charging. Alright, and the battery is plugged on firmly. Alright, so let me continue the disassembly. Okay, so board is out. What? Was the bias removed? I'm seeing some cleaning mark here. Oh, let me do my inspection as usual. So I was looking at the bias strip here and it just looked at it around the area here is a bit wet. As in it was like cleaned. That clean mark there. Alright, so I'm just doing an inspection here, and especially in the charging section here. Alright, so this is the charging control chip, ISL6259. Alright, so I'm just inspecting here, especially on around the EC area here. The EC seems as if it is replaced because I'm not seeing the silicone epoxy around it. I'm not seeing it, so it seems that the EC has already been replaced. Interesting. Or they just reflowed it then, maybe. Alright, the board on this side of the board looks pretty fine. Alright, let's see down here at the bottom edge of the board, 4942. Yeah. Okay. It's looking good. Alright, it's not charging. Alright, so I'll get the charger, DC jack. Alright, so that one is there. Alright, let me connect my battery. My testing brand new battery. This is a brand new battery here. Alright, so let me see if it can turn on from the battery. Alright, so I'm just grounding pin number 5 here. Alright, let me feel. CPU, nope. CPU is still cold. Fan is not spinning. So it's not turning on from the battery either. Alright. Five volts is there? No. 3.3 volts is there? No. What's the voltage on the battery? Let me see here. Nothing. I haven't charged this battery in a long while. This should be PP bus. Yes, I get 10 volts coming from my battery here. So my battery is producing 10 volts. Am I getting LDO 5 volts? No. Am I getting PP 3.4? Yes, I get 3.4 volts at PP 3.4. Yes. Is the EC working or not? SMC reset is there. 3.3 volts on one side and 3.43 volts on the other side. So the SMC reset is there. Yes, 3.4 on next side. 3.37. That's fine. So it's getting reset signal, it's getting supply, so it should, in battery mode, the 3.3 volts will not generate, so it needs the switch. Alright, I'm plugging in the charger now. Alright, I plug in the power. Alright, the current there is 600 milliamp. Yes, the CPU is hot, it's fully on, but it's not charging. Could it be that the DC jack is bad? I'm going to try another DC jack. The Zener diode on it is not burnt either. The Zener diode is not burned, so I'm going to try another DC jack. I'm going to try another DC jack and see what happens. DC jack can also cause the battery not to charge. Alright, let me find one. Okay, so I'll open the schematic. Alright, so it's a A204924. 820-4924. Alright, so it's a A1502 2015, yeah? Alright, so we have this one. I'll open the schematic and the board view as usual. Alright, schematic and board view is now opened. Alright, so we're going to look for the battery terminal. So the battery terminal is here. It's J7050, and I'll do a search here for the battery terminal. This is the main connector here, as you can see. So we have SM bus clock, SM bus data, we have system detect, which is the battery insertion and detection signal, and it also acts as the battery temperature control signal, which is used to tell the EC the temperature of the battery cells, and it's also used to detect the battery to tell the EC that the battery is also inserted, because inside of the battery there is a thermistor inside the battery which is acting as a pull-up resistor, and there, when you connect this to ground, as you can see, this is connected to ground, right? If you, this pin will normally connect to another resistor, as you can see. So I'm going to copy this signal, right? So I'm going to search for it. All right, this is a alias. See, there's another resistor here to ground, right? So when you connect the battery, all right, let me get my pointer fix. Alright, so when you connect the battery, as I said before, inside of the battery there is a thermistor inside of the battery. This is the symbol for a thermistor, right? So the battery has its own thermistor, and this is a pull-up line, and this is the pull-down line. So this line should be 3.3 volts, right? So when 3.3 volts goes inside of the battery to pull up this thermistor, this battery, this 3.3 volts will, and this 10K resistor, normally inside of the batteries of a laptop battery, sometimes, most times, it's 100 kilo ohm resistor. The thermistor is a normally 100K, and this is a 10K, right? So this will split the voltage in more than half, it's less than half, sorry, and it will indicate to the EC that the battery is present and it's inserted, right? So this is the way how it is detecting the battery, because there's a thermistor at the same time. When this thermistor gets too hot, what will happen is that this resistance will decrease to maybe about 50, or if it gets hotter and hotter, it drops to about maybe 30, and the voltage value will be different. So it will indicate to the EC that there's a problem. So some over temperature is taking place, it will stop charging the battery, right? Because they don't want the battery to blow up in your computer. So this is how they put the thermistor inside of the battery. So when you connect the battery, this resistor inside of the battery, and this resistor on the board will become a voltage divider and cut that 3.3 volts to a lower voltage. Sometimes it's 1.5, sometimes some systems it's 0 volts, right, depending on the system and the configuration of the motherboard, and it will tell the EC that the battery is inserted and it's detecting the battery. So that's how it works. So we need to check here if we're getting any voltages, right, and we need to check here if we're getting 3.3 volts here and a constant waveform from the EC, right, and then I'm going to go through that steps of first. We're going to check pin number 13, pin number 14, and we're going to check pin number 15. Okay, so as you can see here, so we have this part here. As you can see, we have SM bus underscore SMC underscore 5 underscore D3 underscore SLC, and this one, as you can see, is the same underscore SDA. I checked here and I get 384, and I checked here and I get, see, as you can see, I get 469 here. It's giving me the resistance value here, 469, right? I got 480 right here, but this one give me 380, and they didn't complete some of the so this one is, I got 469. This one is giving me 380, but they didn't put it here. They only put the value right here. They put some of the values here on the resistance, as you can see, for some of them on the board. All right, so here, as you can see, it's connected to a Zener diode here. So this Zener diode, as you can see, this is normally called this is an anti-static diode rather here, right, to prevent any spike that you can induce on this line, and it will do a reverse conduction, because when the positive side of the diode is connected to ground, it becomes a voltage regulator diode, and it is also using as a clamping diode, right? So you can call it a clamping diode, which is going to stabilize the voltage to a constant 3.3 volts, right? Any static that is occurred on this line due to electromagnetic interference, right, it will automatically do a reverse conduction, right? It do a reverse conduction, and then it will keep it stable based on this diode that it is in the circuit. So you'd have to check the data sheet for this diode to see if it is constantly keeping it at 3.3 volts. It's a reverse breakdown of 3.3 volts, which is the typical voltage breakdown value, right? So this is called an anti-static diode, which is similar to a transient suppressor diode, which is used to clamp the voltages to stabilizing, or you can call it a stabilizing diode. All right. So first, I can move this diode out of the way. I'm going to remove this diode out of the way, and I'm going to see the voltage difference, the impedance difference on the clock and the data line. First, I'm going to check if I'm getting voltage first. So I'm going to check the voltages. Alright, so I'm going to connect. It will turn on by itself. Alright, so let's see if we're getting 3.3 volts on those pins. And I'm getting 0.8 volts. That is incorrect. Next pin, I'm getting 0.2 volts. That's not correct. So I'm not getting any voltage on the battery terminal for the clock and the data. Hence, we can't get a waveform. See, this is incorrect. I'm getting 0.8 on one side, and the next side I'm getting 0.2 volts. So that's incorrect. So first, so I checked the resistance already, and it is abnormal. So I'm going to get the oscilloscope now to check if I'm getting any wave, or if the EC is trying to send a waveform. Okay, so I have the oscilloscope now ready. So I will connect the probe here on the ground. Hope it's grounded. Let me see. Can I touch it with my fingers? I can see I'm getting a response. And I'm going to connect the power supply. Alright, so I'm going to see if the EC can communicate with the battery. Alright, so checking now. So I'm going to give power, and I'm not getting a waveform. As you can see, it's trying to doing something there, but it's not getting the correct information there from the EC. The EC is actually trying to read. Alright, let me increase my time base. Alright, so I'm going to increase my time base to roughly about 10 milliseconds. Right, and I'm going to give power again. Alright, so take a look at the oscilloscope again. I give power. And I'm not getting what I'm supposed to get. This is the clock. Let's check the date. I'm going to check the data. We're getting something there. The data is trying to read there, but it's not perfect. The waveform is not perfect there. Let me go again. As you can see, I'm getting spikes, so that indicates that it's detecting a short. That's a short detection. Alright, so I'm going to remove this diode. Go under the microscope. Alright, so this diode, this little diode here, this is the diode. Alright, so this is the transient suppressor Zener diode. Alright, so I'm going to remove it. Alright, so I'm gonna add some flux. Alright, these diodes are very important. As I said before, they are anti-static diodes, and they prevent any form of static electricity to hit the EC. So the aim of it is to protect the embedded controller. Thus it doesn't send an extra 5 or 10, 15 volts to that EC. So what this does, it's a sacrificial component then in most cases. So it does a reverse conduction, and if the voltage of this, that is withstand value that is induced on that line is too high, it will break down and then break to protect the line from any static electricity due to electromagnetic interference. Oh, sorry, I wasn't under the microscope. Alright, so I'm going to just thin the legs with some leaded solder so I don't put as much heat to burn or to melt the battery connector there. Let me see at this at 330 degrees. Alright, so let's go. Right, we have these tan capacitors here. They don't like heat, and when they pop they smell very bad. So I want to remove this as quickly as possible because I don't like to put too much heat on these tantalum capacitors. Alright, very good, excellent. Now I'm going to check the resistance now on the data on the clock pin and see if I'm getting any different reading, if there are any changes. Alright, this one. Oops, I'm not on. Alright, here we go again. I get 445 on one pin and the other pin 447. Excellent. So this is what I wanted. So I get 450. Let me go directly on the battery connector. This is the clock. I get 445. Remember before I was getting 395 and this one was giving me 480. Now I'm getting 455 on one pin and the other pin 459, and that's not quite off, but it's in the range, right? So yes, 460, 463, not bad. 463 here, and the next one 465. So I'm going to plug in the charger now and see if I'm getting 3.3 volts on that line. Alright, so I'm going to give power. Let's see if I'm getting 3.3 volts. Yes, and I'm getting 3.4 volts. Excellent. See, 3.4, and that is clock and data. I'm getting 3.4. Now I'm going to check now and see if the oscilloscope is actually detecting, and the EC is now reading that line. So once the battery is plugged on, it will get all the parameters of the battery, and then it will charge the battery. All right, so clock. All right, so I'm gonna turn on back the oscilloscope. This is the clock. I'm gonna give power. Alright, here we go. Take a look. Oops, I'm not getting anything. Am I? Yes, I'm getting signal there. Let me go again. There we go. There we go. Now we are getting proper waveform there. So the EC can now communicate with the battery. Alright, let's check the data. Hold on. I wasn't on it. Yes, I was on it. Not getting anything. Oh, there we go. See, we are getting a wave there. That's a data line. Excellent. Let me go back to the clock again. Excellent. Excellent. So now I'm getting waves. So the EC is now communicating on the line, and the EC is constantly talking on the SM bus line. Alright, so this is the SM bus, or you can call it the I2C line. Alright, this is the data. Excellent. Alright, so I'm going to connect my battery again, and then I will put back another Zener diode there, and I will put back another Zener diode. So I'm going to connect my battery. First, let me put back a Zener diode first. So I got a donor board. I'm going to take the Zener diode from the donor board. Okay, so I now have the replacement part from a donor board. So I'm just gonna prep the board here with some leaded solder, the pads rather, making sure that they're nice and shiny. Alright, there we go. And I have here, I've took it off the other board already. So now I'm soldering the replacement. Alright, there we go. Alright, so I'm going to check the resistance now. Clock, 391. Data, I get 400. I'm just going to make the board cool. Alright, so I'm going to check again. I get 337 on the data side, on the clock side, 338, 339, 340. Let's go again. 340, excellent. So the data and the clock resistances are okay. Alright, so now I'm going to connect the battery. Right, so let's take a look at the DC power supply there. As you can see, we're getting 19 volts there, and the current is going to be consumed. Let's see. Alright, so I have 800, 1 amp. Okay, excellent. 1.2 amp, 1.4, 1.6, 1.8, 1.9, 2 ampere. And it should go to 3 ampere, 3.3 ampere maximum. And then it's a fast charge there, so it's charging. Ah, lovely. So it's now going to 3 ampere, and that is perfectly fine. That's what I want. That we weren't getting that before, so it's now charging, as you can see. 2.4, 2.5. Ah, 3.3 ampere. There we go. See that? It's Christmas. You see this? It's saying job done. Excellent. Alright, so as you can see, I'm getting 2.3, 3.2, and it's charging. Alright, so I'm going to put the unit back together now, and then final test. As you can see, it's now running from battery, and the fan is still spinning. Alright, so I'll pause and get back to you when I'm finished assembling. Okay, so it's now assembled, so I'm just going to plug on the battery connector now of the customers. And now I'm going to see if this battery actually charges. I don't like how this part looks. These elongated, so I hope the battery can charge. I forgot to put these screws. Let me put them back. Alright, so everything is checked. Alright, so let me see if it can turn on from the battery itself. Here, listen for the chime. No, battery seems dead. Alright, so I'm plugging in the charger now. As you can see, the current is now 1 amp. Ah, the customer's battery is charging. 1.2, 1.4, 1.3, 1.5, 1.3. It's not charging the way I want it to. It should be higher than that. Maybe it's well dead. One 1.4, 1.3. It seems the battery is well dead, so I'm just going to let it boot up, and then I'm going to turn it off and then see what the current is in an off condition and see what I get there. Well, it's charging. I wasn't getting any 1 amp. I was getting less than an amp, like 600 milliamp thereabout. So this battery is not, I don't think this battery is 100% in good battery health. Alright, so I'm going to turn it off. As you can see, I get the Thunderbolt icon there. I wasn't getting that before. Alright, the lightning bolt icon there. Oh, it's off. I get 360 milliamp in an off condition. So it is not getting fast charge, and I see that, I know that. So I'm going to watch it But the laptop is fixed now, the job is done. So yeah, all right, so I hope you enjoyed the video, and I hope you like and subscribe and let me know in the comments what you think about this video. Right, so this is my last day on for my repair jobs. I will be on vacation, so I'll see you again in another video. All right, bye.